Hello everyone. I'm still on potentiometer, okay, calculations. And this will be the last question I will treat on potentiometer, right? I've treated about two different types before. Please watch them. Remember, I still tell you that potentiometer is used to measure or compare two cells or batteries, okay? So I would like you to continue to watch my videos, okay, to learn, okay, and also if you are above it, you can learn to teach your younger ones or your children, right? Now the question says a potentiometer is 100 cm long and it has a resistance of 2.5 ohms. A knife cell under test gives a balanced point at 62.5 cm, right? A Leclanche cell gives a balanced point at 70 cm. If the EMF of knife cell is 1.25 volts, calculate the EMF of the Leclanche cell. That is number one. Number two question from it says calculate the current flowing in the potentiometer, okay? Now let's calculate for the first one, okay? We still use our formula which says E1 all over E equals to L1 all over L2. E1 is the EMF of the first cell, which is knife cell, okay? E2 is the second cell, which is Leclanche cell. We are comparing two of them. Then L1 is the balanced length of the first cell and L2 is balanced length of the second cell. And they ask us to calculate the EMF of the Leclanche cell. We've known this one already to be what? They have given it for us 1.25 all over E2 we are calculating equals to L2, which is 62.5 all over, that is L1 for this, 62.5 all over L2, which is 70. Now, we do cross multiply, okay, E2 times 62.5 will be 62.5 E2 equals to 1.25 times 70 will give us what? 87.5, okay? When we multiply 1.25 times 70 will give us 87.5. Now we are looking for EMF of the Leclanche cell, okay? Then we make the subject of formula by dividing both sides by 62.5. We use 62.5 to divide this side and use 62.5 to divide this side. After we now 62.5 will cancel itself here, remaining only E2 equals to 87.5 all over 62.5. And when we use our calculator to divide this to get our final answer, what do? It will now give us 1.4 volts as the answer, okay? Now let us calculate for the second one, okay, which say the current on the potentiometer, okay? Now the current on the potentiometer, we first of all, we know that the resistance of wire is equals to resistivity of the wire. I've done this before, times the length of the wire all over area of the wire, cross-sectional area of the wire. Now this is what we use to calculate for the resistance of the wire when under knife cell and also under Leclanche cell, right? So they have given us the resistance of the potentiometer to be 2.5 equals to, we don't have the resistivity of the wire of the potentiometer, okay, times the length of the wire of the potentiometer, which is 100, all over cross-sectional area of the potentiometer wire, right? Now let us make this subject of formula, okay? The resistivity of the wire of the potentiometer. So now the resistivity equals to 2.5 times this area, okay, all over 100, which will now give us what? When we divide 2.5 divide by 100, what will we get? We now get 0.025, which is the area, okay? We are still carrying the area forward, right? Now, this is the resistivity of the potentiometer. Okay, now why using the knife-edge cell? Okay, now let us calculate for the resistance. Why using knife-edge cell? Now, the resistance why using knife-edge cell is equals to resistance of why using knife-edge cell is equals to resistivity, which is we have gotten to the 0.025, that is constant now, okay, times the area, okay, then times length, that is balance point when we use knife-edge cell, which is 62.5, all over cross-sectional area of the wire. So A down here, we cancel A here, okay? We now have 0.025 times 62.5. What is the answer? We use our calculator. We have 1.56 watt, to 5 ohms. Okay, this is the resistance while using a knife-edge cell. Then the resistance while using Lagrange cell, will now be the same formula, which is the resistivity of the wire, which is 0.025 cross-sectional area, okay, times cross-sectional area, that's what we have gotten, times the length of the balance length of Lagrange, which is 70. Where is it in the question? 70 over cross-sectional area. So that A here cancel A here. We now have 0.025 times 70. What do we have? We now have 1.75 ohms. Okay, using these two resistance, we can now use any of them to get the current flowing in the potentiometer. Using any one of them, we know our formula that current is equals to volts all over resistance. And our voltage here is the EMF of the Lagrange cell or knife-edge cell. So okay, let us use now knife-edge cell first. The voltage of the knife-edge cell is 1.25 up here. Abi 1.25 all over resistance while using the knife-edge cell, which is 1.5625. And when you use your calculator to divide this right now, you will now have 0.8 ampere. Then if you decide to use the resistance of Lagrange cell, we use the resistance of Nyquist cell here. If we decide to use the resistance of Lagrange cell, it will still get the same value. We still have our current is equal to volts all over voltage all over current, and which will now give us our voltage for the using the resistance of Lagrange cell, and what we calculated from the voltage of the Lagrange cell, that's EMF of the Lagrange cell, is 1.4. EMF of the Lagrange cell, first one calculated is 1.4 volt. So we use the 1.4 volts all over the resistance of the Lagrange, which is 1.75. And when we divide this up there, it will now still give us the same 0.8 ampere. So this is a wonderful question from potentiometer, and it is the last one I'll calculate. I'm now entering a topic in physics, okay? Taken from the physics subject. Please, if you like what I'm doing, please learn it and teach your children and younger one, okay? Or you direct your younger one to you to be watching it, right? Share them to the people that need it. Share it, comment on that, and like it. Thank you so much as you follow and subscribe to my YouTube channel. May God bless. Thank you so much.